I'm Jason Patton. I'm here with the Center for High Throughput Computing at UW-Madison, and I'm gonna give a quick introduction to the Python API, the Python bindings, um, and then go into a little bit of a tutorial. All right, so if you haven't already done this, please, if you are planning on following along with the interactive tutorial, go to the HTCondor documentation, and then go through the API link. Let's see if I can get a better icon here. No, okay, I'll just go with the arrow here. So you want to go down to the API, application programming interfaces link, go on to Python bindings, and then to the HTCondor Python bindings tutorial, and click the launch binder link. And that'll get you where you need to go for later. All right, so if we go back a few years now, approaching 10 years now, we have all these nice command line tools. Christina just demonstrated two of them with Condor, or I guess, yeah, two of them with Condor Q and Condor History. Pretty much anything you probably want to do with Condor, you can do with these command line tools. But if you ever wanted to do anything extra, let's say set up some kind of web client. In the past, we've had this SOAP client. You had to kind of wrap these tools and whatever you're trying to work with, which is not very neat. Requires parsing of shell output. There's something missing here in the middle if you wanted to do anything extra with the Condor tools, or if you wanted to do any kind of automation with HTCondor. And so that's why we came up with the Python bindings. Basically, the idea is anything you can do with the command line tools, you can do with Python. And so now you can create all sorts of neat integrations. You can create RESTful clients, workflow managers, monitoring tools, so on and so forth. And while the goal is to reproduce all the features that we can get with the command line tools, there's still some things that are missing, but there's also maybe some things with the Python bindings that you could do that you can't really easily do with the command line tools too. So the design philosophy for the Python bindings is that just like with the tools themselves, everything is based on class adds. But we also want to make it very Pythonic. So the idea is anytime you're working with a class add, it's going to be just like if you're working with a dictionary in Python. We also want to be backwards compatible. So to our detriment, sometimes we make APIs stick around as long as possible. If we absolutely have to deprecate something, we'll try to throw a deprecation warning in many releases before we take away anything. And then these bindings are supposed to use native code. They're not just fork execing the command line tools in the background. So they should be fairly well performance. And like I mentioned before, we aim to be complete with these. At least I think what we've done is any automated tool that you've developed in the past using the command line tools, you should be able to do with the Python bindings, and hopefully a lot easier with the Python bindings. So since Pythonic is in our design philosophy, we've tried to also use that for other parts of HTCondor, including our documentation. So now we have our documentation up on Read the Docs. This is going to look and feel a lot like other Python documentation that you've seen for a lot of libraries. And then, as we'll get into in a little bit here, the tutorials are Jupyter based. We have this nice binder link that you can go to launch the tutorials and run through them yourself, rather than just having to look at pre-rendered output. And then for these tutorials, we would love to have your feedback. Anything that you think could be done better, we'd like to hear from you. And not only does email work, but you can also go through on GitHub and send in a PR if you see anything missing. I also want to give a shout out to the developer of a lot of the tutorials, Josh Carpel, our former collaborator. He did a lot of the work to get these up and going. One question that comes up a lot is how do I actually install the Python bindings? In general, if you're an administrator, you can get them the usual ways that you install HTCondor, but not a lot of us here are administrators. So we also make these available via pip install in Python. So pip install HTCondor should get it into whatever environments, virtual environment you're in. Also, thanks to the help of Duncan McLeod at Cardiff, we've got these available via Anaconda, also using the Conda Forge channel. And those work for Linux and Mac. On Windows, you can get them through the regular installer for HTCondor. And one thing I want to point out is up until now, we've released the bindings for Python 2.7 and 3.6 for Windows. Starting in 9.9.0, this will only be Python 3.9 until we decide to go to 3.10, 3.11, and so on. On Mac OS, you can get this via the system tarball, but again, we've just somewhat recently, I think since the last time I gave this talk, we've added this to Anaconda as well. So Conda install will work for you as well on Mac OS. Usually this time of the presentation, I bring up big changes that have happened to the API. Fortunately, there really hasn't been any in the last year. One thing that I think I've brought up a couple times now, but it's just to make sure that it's fresh in your head, is that we do want to try to get rid of these user controllable scheduled transactions at some point. Oftentimes in past documentation, we've used these to show we've used these transactions to submit jobs. Instead, what we want you to do now is use the schedd.submit method with submit objects. And if that sounds foreign to you, we'll hopefully demystify some of this in a little bit. And as always, it's always good to keep track of changes in the release notes. We'll try to give you a heads up if something's going to change. So just again, if you haven't gone through the docs to find the tutorial and launched it, now's definitely the time. It might take 2 or 3 minutes to launch, but we're going to go ahead and jump over into it. All right, so yeah, here again is if you need to get through there on the manual real quick. APIs, Python bindings. Oh, yeah, what's the mirrors button again? Yeah. Okay, thank you. Everything's looking on Zoom? All right. I'll try to hide the, just escape out of that. Oh, yeah. Okay. So APIs, Python bindings tutorial, Python bindings tutorials. And then there's this little nice launch binder link, which I'm not going to click now because we have a blank page. What the heck? Well, that's what you get for doing live tutorials. We might have this open in a different window, actually. Let's see if this works. I'm just going to test real quick here. So while I'm doing this, I can introduce you, if you're not used to the Jupyter environment, this provides a nice browser-based kind of shell into Python. And you have these cells where you can run Python code. So it looks like this is working. So in each of these cells, you can type in some Python code. You hit either there's this play button up here to run whatever cell is active, or you can hit Shift Enter to run it. Another thing with the Jupyter environment, and this might be useful to just show similarities between Python and the command line tools, is you can pop open a terminal on the same machine that all this code is running. So we'll get back to that in a little bit. But for now, I'm going to jump into the first tutorial here. submitting and managing jobs. And a lot of this documentation you can kind of read on your own time, but we're going to go ahead and try to run through some of these code blocks here so you get some idea of what's going on. So the first thing we have to do is import the HTCondor library itself, and we're also importing the class add library. These are right now 2 separate libraries. That may change in the future, but for now these are 2 separate libraries. So I went ahead and ran that. You'll see the number. There's a little number that shows up here on the left every time you run a cell. And the first thing we're going to talk about is the submit object that I briefly mentioned before. So this is kind of your analog to your submit file. So just like you would do Condor submit, my job.submit. Here you can create a Python object that contains all the information about a job. There's a couple different ways you can feed your job information to this HTCondor.submit. Whoops. This HTCondor.submit function. In this case, we're using a dictionary, and this looks a lot like a submit file, except that this is, instead of executable equals, it's executable colon, key colon value pairs. So we're going to create a submit object that's going to run the hostname command. It's going to spit out hostname.out, hostname.error, hostname.log, and request 1 CPU, 128 megabytes of memory, and 128 megabytes of disk. Now, when I run this is not actually going to do any kind of job submit, but it's just going to create this hostname job object in memory. I apologize. To right click on this mouse is very, very touchy. But if you print out this hostname job object, you see you get out pretty much exactly what you would have defined in a submit file. So the next step then is we have the submit object. Now we actually want to run a job. The first thing you do is you need to get a schedD object. You do this with the HTCondor.schedD function. And then, as I mentioned before, you use the schedD.submit method, and then you just feed it that job object, that submit object that you created before. And we'll go ahead and do that, and it's going to print out the cluster ID of this job. So at this point, we should have submitted a job. I mean, there's nothing here that really shows us that. If we want to go back and check on the command line, we can check for ourselves that we've actually run something. Now, Condor, this job probably ran really fast. It's just running the hostname command. We check the history though real quick. You can see that bin hostname command was run a little bit ago. So indeed, we have submitted our first Python job. So let's go a little bit further. So that's submitting one job. What if we want to submit a whole bunch of jobs? Oops. This is just showing exactly what I just showed before, that our job actually ran by looking at the output file. One thing about Jupyter is all these files. There's a little file browser here on the left. So when that job ran and completed, it's these, the hostname.log, hostname.out files that we had mentioned before in our submit file. So we just saw how to submit a single job. How about submitting a whole bunch of jobs? You'll notice that we're going to create another a submit object here. But one thing you'll notice that's different about the submit object compared to a submit file is that there's no queue command. So what if we want to run more than just a single job? All right, so we're going to create these sleep jobs. They're going to run for 10 seconds because that's the arguments here. Again, very similar to the submit file syntax here. So we're going to create the sleep job submit object. Again, nothing has actually been submitted yet. No jobs have actually been submitted yet. It's not until we come down here and get our schedD object and actually run the schedD.submit that we actually run the job. And this time we're actually going to add this count equals 10. And so let's see what this does. So now we've got a cluster ID of 2. Again, we could go, there's ways to do this. I'll get into this very shortly, how to actually query if we, what's going on with the sched-d, have we actually submitted jobs, kind of what Christina just talked about, what the heck is happening with our jobs. But we can go over to the terminal and just use what we already know and run convert Q, and we can see, indeed, we've got 10 total jobs, 8 of them are running, 2 of them have already finished. So can we actually query these jobs from Python? And the answer is yes, of course. We want to try to replicate everything that we can do with the command line tools with Python. And using the sched-d object that we created earlier, we can query it. And we're going to use the cluster ID of the jobs that we just submitted. And this might be empty now because everything is probably already complete and has exited the queue. So we can go, we can just easily go back and resubmit all these jobs again. So now we got a cluster ID of 3. And if you run sched-d.query, again, we're looking for a cluster ID matching the cluster ID of this result object that was created when we ran sched-d.submit. And now we actually got some output from this. You can see we've got the 10 jobs that we submitted, right? Count equals 10 jobs that we submitted. They all have the cluster ID of 3, and then we have the process IDs going from 0 through 9. But we didn't just talk about, submitting, queue-in jobs. We've talked about, queuing so many jobs using lines in a file or whatever extra data that we want to have and iterate over to submit multiple jobs. So we can do that with the Python bindings as well. Here we've got kind of we're going to just create a whole bunch of files. That's basically all this code block does. I'll leave it. You can come back and see what this does later if you're really curious how this works. But the most important thing is that these files are going to be created and they're going to say hello from job and then some random text. And he's got print spit out just to give an example of what this looks like. It spit all these files into this inputs directory. So we can look at what one of these looks like. It's just going to say, yeah, hello from job, blah, 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 ECUXL in this case. And so we want to submit one job for each of these files. How do we do that? Well, we have all these files in this inputs directory, and we can just get a glob of all of those and get a nice Python list of all of these files. And then we need to create our submit file, or sorry, our submit object. And all our submit object, all that our job is going to do this time is just print out the contents of each of these files using the cat command. And here you can see we're using some submit variables that we haven't defined yet. Input file name, which we're going to use as the arguments to the cat command. And then for transfer input files, we're going to give it this input file. But again, no Q command to actually define what those are yet. The way we're actually going to define these is using something called item data. And what item data is going to be a list of dictionaries. And each item in this list, each dictionary in this list is going to have a key that pertains to the variable name that we used in our submit object. And then the value is going to be whatever value we want to use for each job that we submit. So for our list of files, these files from inputs, we need to create a list with 5 objects, 5 dictionary objects. And then each of those are going to have the input file name and input file name set to those files, which is all that this code right here is going to do. So for each path, that we have in this input files list, we're going to create a dictionary that has input file, which is going to be the full path to that file, and then just the name itself as the input file name. All right, so here are the contents of our list, our input data list. Now when we submit this job, instead of saying we just want 5 jobs, we instead pass it this item data list. We make sure to mark it as an iterable. And when we do that and query the schedD, you see now we get those 5 jobs back. So we just submitted these 5 jobs. The arguments are, they have to do with the file name, and then the transfer input has to do with the absolute file path to transfer those files, and so on. And then we've got this little loop here that it's going to check for the output from these files. I was talking long enough, the jobs already ran. So we can see, just like we mentioned before, those files had like, hello from job, ECU, blah, blah, blah. Do we see that here? Yeah, we see that right here. Finally, when it comes to submitting jobs and managing running jobs, we have these 2 additional methods to the schedD object, which are edit and act. And edit's going to do just like we mentioned, Christina mentioned before, with changing how much memory your job wants, or it could be anything, but how much memory your job wants, how much disk your job wants, so on and so forth. So we're going to do that with a couple jobs right now. So we're going to submit a whole bunch of sleep jobs that are supposed to sleep for 10 minutes. So there's our submit object. We submit the submit object using schedD.submit. And let's say that we did not request enough memory. 128 megabytes was not enough, and we caught this before the job ran. We could go through and say, oh, I'm going to edit this job and change that. In this case, we've got a very simple edit. We're actually, instead of editing any kind of request, we're just going to edit this attribute named foo and call it bar. And so we ran the schedD edit command ran, and then we queried the schedD for all of our jobs, and you can see that they all now have this foo equals bar in the job add. Similarly, we can come over here and what we're talking about with what are our jobs doing. We do we come over here and we can say what's foo in all of our jobs. You can see that they are indeed all bar. And then finally, for holding and releasing, and what else did we mention? Hold, release, remove, vacate we won't really talk about. We can use the Python bindings as well here, and this using the schedD.act function. So here I'm going to feed it I'm going to feed it all the processes that are less than or equal to 1 in the same cluster that we had just submitted. And we're going to hold those, and you can see now that there's a difference between the first 2 processes in our cluster. These 2 have job status 5, the last 3 have job status 2, and in this case 5 means held. Again, we can come back over here, and this was Condor Q. Oh, what was it, Christina? Status? What? Help status. Same thing as what we had mentioned, what Christina mentioned in the previous talk. Same numbers there. And then similarly, we can do the same thing to release release all those jobs. Instead of HTCondor.jobAction.hold like it was before, it would be jobAction.release. And you can see those 2 jobs went back to idle now, where one is idle. Finally, if we decide we don't want these jobs around anymore, we can remove them. Again, same thing as before, but instead of job action hold or job action release, it's job action remove. All right, I'm going to leave these exercises as homework for you all, as well as the rest of these tutorials. But hopefully this gives you a nice taste, a nice introduction for using the Python bindings. And with that, I'll jump back over to PowerPoint. And just mention that if you have questions, I'm going to take them here in a little bit, but also our HTCondor users mailing list is a great place to ask Python bindings questions. And thank you. I'll be glad to take questions now.